over to Wim.
Yeah, so thank you for the quick intro. Indeed, all welcome to having you in our webinar. Actually, we are very pleased to have Rescale as the cloud hosting partner on the call, as well as one of their customers, RCR. But before introducing them and the agenda to you, I'd just like to start off with sharing you a few introductory slides about our cloud strategy. Yeah, and this slide basically summarizes our cloud solutions today and introduces also what we call the open cloud strategy. We all know cloud is not a one-size-fits-all, yeah? And every customer has different requirements, different workloads, different needs. Yeah, this is really showing you that we have 3 cloud solutions that we support today. First of all, on the left-hand side, yeah, I can refer to the private clouds, actually, where each cloud deployment is unique and usually managed by the customer. And on the right-hand side, yeah, you see actually our cloud hosting partners who provide customers with cloud HPC services, addressing occasional end user burst capacity, or where customers can go to, where you can go to for fully outsourcing work in the HPC space. So, and we are very pleased to have Rescale, yeah, organize this on behalf of Rescale, host this event for Rescale. And because Rescale is one of our front runners, is one of our prime cloud hosting partners who provide all software and services, also for private cloud, by the way, and also on multi-cloud environments. And in the middle, by the way, you see our public cloud providers, and I can say that some of our cloud hosting partners, including Rescale, also offers ANSYS on the cloud infrastructure of these cloud public cloud providers. And here, yeah, you can see that on the private, yeah, on the premise side, customers obviously manage these environments themselves, and on the right-hand side, as I already mentioned, they go and ask the cloud hosting partners to manage the environment on their behalf. Here, I'm showing we are open in terms of licensing. That's very key. Yeah, that you are able to reuse your licenses. You can, your existing licenses can also be re-hosted in the cloud, but you could also think of yeah, using our pay-per-use licensing for peak capacity and for peak demands in the cloud. And I'm sure that also Rescale will be talking about it in a couple of minutes from now. But probably the most common first questions we are always getting from our customers about ANSYS on the cloud is how will licensing work? And therefore, I'd like to address that on this slide. As I mentioned before, our fundamental licensing model is open to cloud. And so let me walk you through the details. So our customers obviously are currently, most of them are using their on-prem infrastructure where the license manager is controlling the execution of ANSYS on-premise. But when you choose to run ANSYS on the cloud, for example, on Rescale Cloud platform, one key point is really that you don't necessarily need to buy new licenses or move licenses, yeah, to the cloud data center. You can reach back, yeah, through a secure firewall connection also and use the licenses you already own. Yeah? That's an option. There are other options as well. Yeah? If you want to isolate, for example, your work on the cloud, yeah, or yeah, if you need added license capacity for the cloud, you can install also your licenses on the cloud. You can buy obviously also new licenses, etc. Pretty straightforward. You can also use a kind of hybrid licensing scenario, yeah, where you use a combination of on-prem licenses with cloud licenses. we are very open in that regard. And as I mentioned, also you may also be looking to cloud for peak capacity, and where a pay-per-use licensing model would be very, very attractive. And so here is where our elastic licensing comes into play. And here I'm very pleased to introduce you to not only to today's agenda, but also to today's presenters. I'm very excited to have Patrick Butt and Seth Morris from Richard Childress Racing on the webinar. Seth is going to share, and Patrick as well, share with us how their company is able to improve the design process as well as on-track performance of their race cars and through cloud-enabled simulations. I will now further introduce Patrick and Seth to you, and I will do that by extracting some key points from their bios. Seth Morris is actually the CFD team leader and the aerodynamicist for RCR since October 2014. Seth has a Master of Science in Aerospace Engineering from the University of Dayton with a focus in CFD and thermal fluids. Patrick Butt is the Corporate Communications Manager for Richard Childress Racing. Since 2014, Butt has helped develop RCR's overall digital and social media strategy, brand strategy, and public relations efforts, while also serving as communications liaison for Chairman and CEO Richard Childress. Besides Patrick and Seth, as you can see here on the slide, I'm also very pleased to have Rick Knöchel from Rescale as a speaker, who will give an overview of Rescale's cloud HPC simulation platform and Rescale's global multi-cloud HPC infrastructure network. So looking at Rick bio, Rick is the Senior Account Executive and brings over 30 years of global automotive CAE, HPC, and IT experience to today's webinar. Rick also brings a deep-rooted passion and lifelong interest in motorsports, as you can see. With master's degrees in both mechanical and computer-aided engineering from the University of Michigan, Rick has participated in professional motorsports. Last but not least, we will have also Q&A session at the end of this webinar. So let me now hand it over to Patrick, actually, from RCR. Patrick, please go ahead.
Good morning, everyone, and Wim, thank you for that introduction. What an honor it is to be presenting here this morning, and welcome, everyone. We hope today that you just get to learn a little bit more about Richard Childress Racing and kind of how we operate as an organization, and in particular our relationship with ANSYS and Rescale. So just a quick introduction. Like Wim said, I oversee corporate communications here for Richard Childress Racing. I've been with the company for almost 4 years now, and definitely have enjoyed my time here. So Seth, you go to the next slide here. So Richard Childress Racing, we are a NASCAR team that competes in the Monster Energy NASCAR Cup Series as well as the NASCAR Xfinity Series. Our 2017 lineup looks a little bit like this. We have 8 full-time NASCAR teams and 3 in the Cup Series with Austin Dillon, Paul Menard, and Ryan Newman. So we can move to the next slide. So a little bit about RCR. We were founded in 1969. 2018 will be our 49th year in NASCAR competition. So we are one of the longest tenured teams in NASCAR. We, of course, were, next slide, we're founded by our fearless leader, Richard Childress. Richard started RCR literally in the back of his pickup truck and in his garage, and working 15-hour days, and you know, as the team's driver, head mechanic, engine builder, and everything in between. So he is the epitome of the American dream, as we like to say. He started from the bottom and worked his way up, and now is one of the premier owners in NASCAR. So to the next slide. We started. He started as a driver in '69 and raced all the way up until 1981. And in the '80s, he partnered with a guy named Dale Earnhardt. So anybody who's a race fan obviously knows Dale Earnhardt, and his legacy is he is definitely a legend in our sport. Together they accomplished a lot. So anybody that, like I said, anybody that knows NASCAR knows that Richard and Dale Earnhardt were a dynamic duo during the '80s and '90s. So RCR today, we've got 8 teams, like I mentioned, 550 employees. We have 70-plus engineers on staff, and it continues to grow. 4 of them are actually doctoral degrees. Our Director of Competition, Dr. Eric Warren, has a PhD from NC State University, and he is a fearless leader for us as well. So we have 500,000 square feet of production, design, research and development, manufacturing, and marketing. And we're headquartered right here in Welcome, North Carolina, where I'm sitting right now, and Seth is as well. So we are an accomplished NASCAR team. We have over 200 victories, 15 championships, and the first team to win in all 3 of NASCAR's top series. And we're continuing to add to our win total. Like I said, next year will be our 49th year, and our driver lineup is not announced for next year, but we fully expect to contend and compete for wins and championships again next year. Earlier this year, in January, Richard was rightfully honored in the NASCAR Hall of Fame. This picture here is of his wife, Judy. All the way to the left is his grandson, Austin, and all the way to the right is his grandson, Ty, who both race for Richard. So it's a family business, and Richard was honored throughout the stock car racing community in January for the NASCAR Hall of Fame class of 2017. So a little bit about our engineering background. We are a culture of innovation here at RCR. It's critical to be coming up with new ideas on a monthly, if not weekly basis. We put a very strong emphasis on engineering, technology, and custom manufacturing. And we're all working towards a common goal to improve every aspect of how our cars and engines perform. So, Seth, you can stay on this slide here. Technology flows through our entire organization, and you'll hear more later from Seth a little bit about this, but from virtual testing to real-time race analytics, we're constantly learning how to incrementally improve our performance. So we're fighting for tenths of a second on the racetrack. You can't stop a stopwatch that fast, and it's critical that, like I said, we need to continue to innovate new ideas, or it won't be long until we fall behind. The next slide. So how does this define us? We sell ourselves as a vertical design and manufacturing hub. In turn, we've partnered with a number of leading technology companies who've integrated their cutting-edge offerings into our operations. We have some Fortune 500 partners and some great partners that have come along and developed some of their products. So I'll give you an example. Dow, who we brought on in 2013, has developed a proprietary lubricant for our race cars called Molykote. They've implemented safety impact foam into our race cars. Another company that we have partnered with called Akuma North America. They have a technology center on campus, and they build all of our race parts. So one thing unique about Richard Childress Racing is we build approximately 95% of our race cars built right here on campus in Welcome. We have a machining and manufacturing and build our own engines, our own chassis. We do our own engineering, our own marketing, and it's a key to our longevity. So, and then finally, PTC, we use their software to design car and engine parts. And then you'll hear a little bit more next from Seth some of our newest partners in ANSYS and Rescale, which he'll highlight next. But again, we're honored to be partnered with ANSYS and Rescale for some of our cloud computing and simulation needs. So Seth?
Hi, thank you, Patrick. So just as a segue, we, as Patrick had mentioned, small advantages can make pretty large differences on the racetrack in stock car racing. And because of that, we engineer and design and manufacture basically the entire race car from the ground up on our 40-acre campus. We machine our own engine blocks from raw castings from General Motors. We design the chassis, suspension, steering components, machine them and fabricate them in-house. Per the rules, we have to purchase the body panels from General Motors, but we shape them to our aerodynamic specifications. And of course, the CFD is an important part of that aerodynamic process. So this is give you an idea of what the aerodynamic process looks like. You have an initial idea. You may draw that up in CAD. It would go into the full car CFD model. Occasionally, there's a closed loop that goes right back into an idea stage right from CFD. Or it may, from the CAD model, go into a CFD subsystem, maybe a closed ductwork system or maybe partial car model. Eventually, all those really make their way into the wind tunnel as the validation. And then the wind tunnel test will validate parts, and they either go on the race car or they don't. And then, of course, at the racetrack and as it's implemented on the race car, feeds new ideas, and you can see how this is a closed-loop design system. To give you some stats on our CFD model, the current CFD model is it jumps between 200 to 240 million elements. We solve to the wall, so we don't use any wall functions. There are very small mesh in very high gradient regions around the car. 95% of the car is modeled, so our CAD does come from manufacturing CAD for the most part, except for the bodies are scanned. Therefore it's highly detailed, so it requires a whole lot of mesh to capture that. It's still not detailed enough, though. Over time, the mesh will continue to grow. That is how it's been in the 6 years that I've been doing this. The mesh has probably doubled in size already. And it will continue to grow for various number of reasons. One example is these flow field pictures at the bottom of your screen here. These are two different cases. One is in 3.5 degrees of yaw, and one is at 0 degrees of yaw. And you can see this underbody jet that is moved positions. If we wanted to be able to capture, the flow gradients in different areas of the model with the same mesh, we would have to refine, this area for this case, and this would be one example of why the mesh will continue to grow. And that's important because, having access to an ever-growing computer or being able to, get more cloud compute capacity is exactly what we're after. So as this mesh grows, we don't have to invest in increasing the on-site compute capacity, especially as it grows faster than probably the, than the hardware is keeping up. So Fluent is linear scale, in the mesh size for the number of processors that we're operating. So we're operating down in this region here because we're trying to turn around cases as fast as we possibly can. But we're also interested in operating in the most efficient region possible. And because of that, we can scale up or scale down without worrying too much about efficiency, compute efficiency. The scale up of the code has vastly improved over the years, and we expect linear scaling much past our ability to generate ideas and create models. And by that, I mean, if we were to ramp the number of cores up, we would increase the throughput, and at some point, the limiting factor is going to be generating ideas and creating the CAD for that throughput. Here's an example of a drafting case that we've performed several of these. These are very large cases, but we actually reduced the detail of the geometry. And then, of course, if we're doing any downforce specific traffic studies like this one down here, our meshes can get into the 500 million element size. And we can't really reduce the detail of that geometry. And this here is an example of different cases that may have larger mesh sizes, which then requires more compute capacity. And so you can see how our demand for compute capacity may change, day to day. So RCR uses ANSYS Fluent on Rescale. Of course, if you're not familiar with Fluent, it's a robust, commercially available CFD solver, capability to solve many problems, different flow regimes. And that's important for a race team, as a race car has many different types of flow. You may have, oil cooling system, could be laminar, or even Stokes flow. You may have turbulent, separated flow over the body. And you may have, water flow in the water cooling system that's turbulent. And then, of course, you could even have conjugate heat transfer problems. And Fluent is able to solve all of these different types of problems, and it's one reason why we use it. We also use it for adjoint analysis, which is to help produce a sensitivity field of a cost function, which may be downforce. So this would tell us, here's a suggestion on moving this body panel this direction to increase downforce. RCR uses Rescale for obviously the top reason, ever increasing performance of computers. So as these new hardware are rolled out, they become available to us immediately, and we can harness the best computers in the world for these CFD cases. And we don't have to keep an infrastructure or HPC cluster on premises. We're a race team, and we don't have experts in HPC. Our computer experts are more for on-track communications and file transfers, and those sorts of all those problems that arise on the computer side are very different in the race at a race team than you would expect. And then, of course, scalability. Like I just mentioned on the previous slide, with different drafting cases may have double the mesh count, we can just scale up with the click of a button. And scalability is obviously very important for RCR. This is an example of our 2015 season CFD cases. Number of cases we ran every single month, and you can see it's not very constant at all. We had two new analysts. Start in December, and so of course productivity was down. Over the next couple of months, the productivity got to a reasonable level, and then we started to experience issues you'll have in CFD, in motorsports, tire jet stability issues, probably known by every single CFD analyst in motorsports, and that hurt our productivity. And then moving on into June, we bumped up again, and then we started running downforce traffic runs with the very large meshes, and that reduced our case throughput in August. And then, of course, December's a partial month, and we have vacation and whatnot, and we see productivity going back down again. A CFD analyst time is preparing and analyzing the solution is small compared to the compute time. We prefer that CFD analysts spend their time analyzing and coming up with new ideas and not necessarily meshing. And then things like the traffic and drafting cases require a whole lot more compute power and don't actually require a whole lot of idea generation as you may be mapping, drag your car relative to another, to another car. And so you're just running a whole lot of CFD cases without a ton of in-depth analysis. And this is another reason why scalability would be important, because we could run these in parallel to our normal development cases. And then, of course, inconsistent usage is another reason why scalability is important. So, all right, so I have a video to show you guys. So this is our first win of this season. And Ryan Newman's the 31 car leading the race, and he was able to beat Kyle Larson through turn 1 on old tires. So a testament to the amount of downforce this guy's got in his car. And he is able to hold off everybody behind him who had new tires, and new tires are very important on these heavy stock cars because they're really heavy. And he holds them off, able to hold them off till the end. We get the win. Pulls onto the front stretch, gets the win. And Richard was very happy, and so were the guys on the team. It's the first win for a couple of those guys. And then, of course, that's the look of defeat there. And this was our second win this season. This was a very important win. We won this on strategy, and we were not the fastest cars in this race. We were in the top 6 or 7 in speed, but strategy helped, and that's an important. CFD played a role in the strategy because of pit stops and fuel filling, and the CFD doing analysis on the fuel filling played into this. And Austin Dillon is able to win one of the most prestigious races of the year over the powerhouse of Martin Truex Jr. and holds them off through strategy. Very big deal for us. And with that, I have nothing else. So I'd like to pass control over to the next person.
All right, very good. Get my screen up here. Bear with me, folks. All right. Everybody hear me all right?
Yep, you're coming through, Rick.
Good morning. Okay, well, thanks, Wim, for hosting and emceeing here, and for both Patrick and Seth for a great presentation by, one of our classiest customers, Richard Childress Racing, and one of our best partners, ANSYS. Appreciate you having us this morning. So how does Rescale fit in with this? Well, Rescale got started by solving some really big compute challenges. Our two founders, our CEO, Yoris Port, and our CTO, Adam McKenzie, run a team at Boeing that were involved with the design of the 787 wing. Now, this was an industry first. It was an all-composite wing. So not only did they have new materials, new manufacturing processes, it was also the first time that Boeing went out and had a lot of suppliers in the supply chain providing these components for them, much like we do in the auto industry. But there were some real challenges, and the team was facing some big challenges in getting the work done. The deliveries were threatened to be delayed, and they needed to come up with some answers very rapidly. Boeing senior management went to the team and said, what do you need from us? And basically the response was, we need a lot more computing horsepower to do this simulation work and figure out how we optimize this design given the materials and the challenges involved. And so what Boeing did was they allowed the team access to all the internal compute resources within Boeing, but only on the weekends, because they couldn't disrupt all the other productive work that was going on. So the challenge was then, how do we figure out how to string all these computing cores together and then leverage them both from a scale up perspective, and a scale out perspective to solve very large problems around structural design, computational fluid dynamics, but also design of experiments or optimization to drive those analyses to come up with an end result. Well, the net was they figured out how to do this, and they were able to take what typically was about a 3-month product development process around this optimization and compress that down into a 24-hour window. They were able to take 150 pounds out of the weight per wing, which leads to roughly $180 million in fuel savings over the life of an airframe. So pretty big problem, real-world problem, big numbers, big computation, required a big compute solution. And thus, the idea for Rescale was born. Rescale's quite an interesting company. I joined them back in March. We've got a global footprint. We've got some very interesting investors. And Gartner picked us as one of the cool cloud vendors for 2017. So it's a technology and a company and a capability that's coming on strong, and you're going to be hearing a lot more about us in the future. What does Rescale do? Our ScaleX platform, the way to think about it is it's a portal, a window, if you will, that can access on the back end any number of cloud computing resources available from the number of cloud players in the space. We also have what we call bare metal partners if we need to get into specific hardware configurations in terms of processor sets or GPUs or other sort of devices. We've got the ability to run and support over 200 software titles on the platform, everything from the classic CAE software titles that you're typically running all the way up to machine learning and deep learning software titles, along with the ability to bring your own, if you want to write your own Python code or other R codes or other sorts of things. Basically, it's a zero IT footprint turnkey solution. We take all the heavy lifting away and basically allow you to run your work with a very simple job flow. We are the industry's leading simulation enterprise leading platform. Again, software, multi-cloud capability, workflow. We've got enterprise features built into the system to allow for project budgeting and management of all the various resources, compute resources, software, and we can provide breakdowns and costing structures so folks can manage projects by content, by group, by individuals, and of course we adhere to all the latest and greatest in data and user security, being a cloud-based approach. We take advantage of many data centers spread throughout the world, and we'll quite often, this allows location-specific support, also, tie it closely to the source of the engineering work that's going on to minimize network trafficking and network traffic and those sorts of things for latency reduction. When you're doing things on the cloud compute, you have to think a little bit differently about the workflow and the process, but the fact that we've got the ability to distribute this work anywhere in the world also gives us quite a leg up. The one thing that is unique to Rescale, unlike others, is we do not own a single stitch of compute hardware ourselves. We're doing this all with cloud partners or bare metal partners, and we're basically creating virtual HPC clusters on demand, paid for only while you use them, and then you turn them off and get on with the rest of your work. Why is this important? Well, what we've seen in the industry is there's increasing fragmentation and specialization around the types of compute servers, the networking, the storage, the processor chipsets, right, with GPUs and InfiniBands and TPUs and FPGAs, and the interconnects, when we start to talk about various things with 10 gig E and InfiniBand and other proprietary connectivity, it's and it's going to get to be increasingly more difficult for companies to keep up with the pace of change in this space. And so Seth made mention of it, and we appreciate that, Seth, that one of the big value props for Richard Childress Racing with Rescale is the fact that we're rolling out the latest and greatest. I should say our cloud partners are always rolling out the latest and greatest. And when we get on those platforms and then install the ANSYS software and the ANSYS Fluent and other ANSYS tools on those platforms, you know, we give our customers availability to the latest and greatest hardware to run the code. And given that seconds matter, you know, we're really a time to solution provider. And as Seth was mentioning, we give them the ability to do more with less time. ANSYS, tremendous software partner of ours. We host the majority of the ANSYS codes. We've got an extensive library of demonstration tutorials on our website and on the platform that are available for ANSYS users. We support work with ANSYS Workbench and job submission through RSM. Variety of licensing approaches. The ANSYS team has been incredibly helpful and supportive in bringing us cloud customers and helping those customers solve their big compute challenges. And you know, what we're seeing is typically customers that are reaching the limits of their on-prem either workstations or workgroup clusters, or even in some cases where they're large on-prem corporate clusters that just are not available. They're not available due to other work, long queuing times, big problems to solve, or sometimes licensing constraints. That's where Rescale comes into play. We're expanding the partnership with ANSYS in terms of supporting their wide range of GUI apps. We have virtual desktop technologies that we've written to specifically take advantage of a virtual desktop that is run on the cloud, allowing you to do both pre and post-processing work on the cloud. Because it's important that you want to view your results and validate your results on the cloud before you start moving large data sets around. We've also got, you know, a great network set up in terms of support with our experts and the ANSYS experts, and we are recently expanding the number of ANSYS resources in the field that are trained on Rescale. So typically in any ANSYS sales region in North America, you're going to find a individual ANSYS software solver expert that will also be trained on how to run that tool on Rescale. So that's just an example of the burgeoning partnership. Just to give you a sense of it from my perspective, I'm probably spending 65% of my waking hours engaged with ANSYS-related projects where customers are looking to run ANSYS on Rescale. We make this a seamless experience for enterprise IT. Seth said it best. You know, they don't want to spend their money on people to run clusters. They want to focus on what their core competency is, and that's building championship-winning race cars. So we take care of that back end. We take care of the heavy lifting. We bring to the table all the IT expertise around all the things that you need to successfully run an HPC cluster, security, middleware, operating systems, patching of the solver codes, and all these various things. And then we wrap those up in a very, very secure environment. We are compliant with the strictest industry security standards, and of course we leverage a lot of these things from our cloud partners. So for example, you know, we have ITAR compliant clouds for folks that have to do ITAR compliant HPC. We're also into the realm of HIPAA, and all these certifications are, we're audited and review these annually, our annual submissions. At the end of the day, it's really about a faster time to solution, and as we all know, time is money. We shorten design cycles, we turn around analysis faster. Problems like Seth and Richard Childress Racing are solving with these CFD problems because they scale up and they scale out. They're ideally suited to the cloud, and it's not uncommon for us to, turn jobs around in half the time that could typically be handled with on-prem clusters. We give the ability to be very flexible, very nimble, very scalable. Again, these virtual clusters are spun up nearly instantaneously and then shut down upon completion of a job. We do offer integrated solutions. We do have customers that have on-prem, and we work with them in establishing hybrid solutions so that workloads and workflows that are best suited to the cloud can run in the cloud. And probably one of the biggest attractions that folks like is the optimized pay structure, where you only pay for what you consume on our platform. This really is a shift of CapEx to OpEx, and it's very important for a lot of customers in this day and age.
Yeah, so many thanks for today's presenters from RCR. Yeah, I'm very excited about this, the progress they're making thanks to cloud-enabled solutions. This is marvelous to see. Yeah, that RCR is taking advantage of cloud-enabled simulations on Rescale's cloud. So thank you, Seth and Patrick, for your very interesting talk. Also thanks to Rick, obviously, for elaborating on your big compute capacity and your platform completely dedicated for ANSYS workloads. So let me now just wrap it up and go into the Q&A session. But before going there, I'd like to point you to a few links, just a few web pages, the cloud -partners page, where you can find further information about Rescale. You can also find through this ansys.com cloud webinars page, and more important, check out Rescale, Rescale's website regarding ANSYS. Check out also the specific case studies. They've just posted a new case study, very interesting story from a company, Optisys, using HFSS, our high-frequency electromagnetics software on the Rescale platform, and then using AWS instances for that matter. So please check it out. Very, very interesting story. Also, I'd like to point you to this upcoming webinar organized by Rescale in conjunction with NVIDIA and ourselves, where we will be talking about how to speed up your ANSYS applications on GPU-enabled servers, but then in the cloud, so that you can, even thanks to the cloud servers and with GPUs accelerated and enable you to increase your simulation throughput. So please check it out and pencil it in your calendar for October 18th.